Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem, count possible ways to construct buildings. This is a medium level question and is the problem of the day on Geeks for Geeks today. So let us go through the question now. There is a road passing through a city with n plots on both the sides of the road. Okay, so let us clear this fundamental thing that has been given. There is a road between two parts. Okay, so there is a city there and there's a road passing through a city with n plots. There are plots in the sense lands on both the sides of the roads. Plots are arranged in a straight line or either side of the road. Okay, so on either side of the road there are plots arranged, means lands arranged. Determine the total number of ways to construct buildings in these plots, ensuring that no two buildings are adjacent to each other. Okay, this is the only fundamental point or the constraint that has been given to us. That is, whatever the buildings that you are going to build on the plot, make sure no two buildings are adjacent. So if you're trying to build a building on a particular plot, make sure the next plot does not have any building. Okay, so that is the thing. Specifically, buildings on opposite sides of the road cannot be adjacent. So do not bother this statement a lot. It might be confusing. It might be like you people might be thinking like on this particular segment, just pretty opposite buildings that is what you people might consider, but please do not get into all these things. Just understand the basic thing that no two buildings must be constructed adjacently. Okay, so using star to represent a plot and two straight lines, or you can say mod for the road, the arrangement for n equal to 3 can be visualized as follows. Okay, so there is a road in between and there are three plots on the either side. So as the answer can be very large, print it mod 10 power 9 plus 7. So these are some examples given. We'll go through it. And expected time complexity is O of n and space is O of n. But we'll be solving this question in much more optimal fashion. Time complexity with O of n and space as O of 1. Okay. So that n goes up to 10 power 5. Okay, that's pretty clear. And the company tags are PU and the topic tags are dynamic programming, Fibonacci. So once I've observed this particular Fibonacci, I was able to solve this. Not I was stuck in this recursion. I was not able to observe the pattern clearly, but when they actually mentioned about the Fibonacci in the topic tags, I was able to decode that yes, this is a Fibonacci problem. So that is the reason I go through each and every segment of the question. That's why I put it in the video as well. So it might be time consuming, but it's very important to go through all those things so that we eventually end up solving the problem without taking any extra reference. So let us go through the question now. So this is n equal to 3 and the output is 25. So why is that the reason? Let us first consider it. So what is the cases? So let us first construct the road like this. Okay, this is the road, and now there are three plots. N equal to 3 in the sense there are three plots on the either side. So this plot here, and plot here, plot here, plot here. So what are the various cases possible? Let us assume you're starting with a building here. Okay, it is starting with a building here. Then the adjacent to it is this. So can you put a building here? No, you are not allowed to put a building. So there is it must be empty. So you can represent it as yes. And once you have got yes here, the adjacent to it have two options. What are those? Either it can have building or it can be left empty. So if I put a building, it will be like this. If I put it empty, it would be like this. Okay, so these are the two cases. Now let us assume you are putting an empty space here. You're not putting a building over here. Okay, you're not putting a building over here. Once you put an empty space here, what are the two options available at this particular point? Either you can put a building there or leave it empty. So either you can put a building here or leave it empty. So I'll write these two here. And once if you're putting a building over here, what is the next option adjacent to it? It must be empty. So it must be yes itself. And what about in this particular position? Because you have kept it empty, you have again two options. What are those? Either you can put a building or you can leave it empty. So if you put a building, it would be B, or if you leave it empty, it will be like this. So that's it. We have covered all the possibilities. So BSB, SSB, SBS, BSS, SSS. So these are the five things that they have mentioned. So these are the five things. And now if we replicate the same thing here, the same thing will also happen in this here as well. So there are also 5 ways possible here. So total how many ways possible? That is 5 into 5. That's actually equal to 25 ways, right? 25 ways. That is the reason output is equal to 25. I hope you people have understood. Now what is the approach to solve this question? Okay, now what is the approach to solve this question? So the naive approaches, as you can completely see, you are working on choices, isn't it? You're working on choices. So if I write the tree diagram for the very first plot, what are the two options available? I can put a building or I can leave it empty space. Okay, I can leave it empty space. Let us assume you are working on this particular case only. So where you have three plots. Okay, three plots. So the very first plot thing is either you can have B, that means you can have a building, or you can have it leave it remain. So first plot in the sense, this is the first plot I'm talking about, this is the second, this is the third. And now coming to the next. Okay, if you're putting a building over here, what is the option for the second plot? You must go with an empty space, because you cannot put a building in the second spot, plot. Okay, so this would be the option for second plot. This is the second plot. And if you're leaving it empty for the second plot, if you're leaving the second plot to be empty, what are the two options now? Either you can put a building in the third plot, or you can leave it empty as well. So there are two options again. So this is for third plot. Okay, this is for third plot. What are the options that are there? Either you can put a building here, or you can leave it empty. That's it, we have reached the end. What about this particular thing? What if you're putting a empty space? What if you're leaving it empty in the very first plot? Two options again. So either you can put a building in the second plot, or leave it empty. So if you're putting in the building in the thing, you can leave it empty, or sorry, you can put a building here, or you can leave it empty. So I'm leaving empty here, I'm writing empty here because I can have a space to write this too again. That's the reason. Okay, and now again, if you're putting a building in the second plot, what are the options for the third plot? You can put a you can only leave it empty. Okay, so that is S. And if you're putting if you're leaving it empty, the second plot, you have two options for the third plot. Either you can go for a building, or leave it empty as well. So what are you can just write those two options here. It would be B, it would be S. So what are the total things that you have got? So this is one combination, right? So if you just see this properly with a blue ink, so this one is one combination, so that is BSB. Another one is this BSS, this is another combination, BSS. And what is another combination? SBS. SBS is another combination, and SSB. Okay, SSB is another combination, and SSS. So once you reach the third plot, that is the final plot, whatever the combinations that you get, that will be the final number of combinations on one side of the road. Okay, on one side of the road. So these are all 5 combinations on one side of the road. So that is what we have seen here as well, the 5 things. And now because the same thing replicates on the either side of the road as well, second side of the road, so it would be 5 into 5 equal to 25. I hope you people have understood. But how are we doing this? This is by recursion itself. So by basic recursion, isn't it? This is a total complete recursion problem. So you can start the very first thing has 2 choices. Okay, so how are we going to represent this? So I'll just erase this. Remember that we are working on n equal to 3 case. Okay, example. So we are working on the same example too. So let us solve the recursion for this example itself. What is that example? There is a road here, and there are 3 plots on the left side as well as the right side. Okay, so what do you see here? What can you infer at this particular index? Or you can just take this to be 0th index, this to be first index, this to be second index. All right, so at 0th index, what is that there? The freedom that you have, you can have 2 options. Either you can go with a building over there, or you can leave it empty. Okay, so the 2 options that are there here is, so you can just start with this space to be 1 and index to be 0. Okay, this is the thing that you'll be starting. So what are the 2 options? Either you can put a building over there. So if you're trying to put a building over there in this particular position, if you're putting a building over here, then what would happen to this particular thing? This should be empty. Okay, there's no other option, this should be empty. So you'll be calling a recursion on space to be equal to 0 and index to be equal to 1. I hope you people have understood, because you have put a building at this space. Because if you have some space, you'll be putting a building, but if you do not have space, you'll be leaving it empty. Okay, and what is the other case? You can leave this to be empty. Instead of putting a building in the 0th index, you can leave this to be empty. So the space continues, there will be a space for the first index, and index would be equal to 1, right? So I hope you people have understood. So I'll just write it properly. Index would be equal to 1, right? And now again come to this particular thing. So because space is equal to 0, space equal to 0 in the sense, that means there's a building over here. So that's the reason this is there is no space to construct a building at this particular point. Now what is the freedom that you can give to the next index or the second index? So that is, you can have give 2 options to the second index. Either it can be empty, or you can put a building, because there is no building at the first index. So what is the freedom that you can give? You can give a freedom of space. So space you can give, and index would be equal to 2. But what is the same thing replicates here. Whatever we have written 2 subtrees here, the same subtree you will write here, right? So space would be equal to 1 and index equal to, so space equal to 0. Because space equal to 1, there are 2 options, either construct a building or do not construct. If you are putting a building here, okay, if you're putting a building in this particular position, then space would be 0 for the next index. So index would be equal to 2 and space would be equal to second thing, this is first choice, and space would be equal to 1 and index equal to 2. Okay, now you have come to index 2. Okay, now you have come to this particular index. Now what are the 2 options? Either you can construct a building or do not construct, because you have a space here. So if you're trying to construct a building, at this point, so what is the recursion that you'll call? Space equal to 0 and index would be equal to 3. And here either or you can leave it empty, space to be equal to 1 and index to be 3. So similarly you can even write here as well. Okay, so you'll be getting some number of things, and finally you'll be calling after this index to be 4, but it reaches this value, right? It is exceeding this value. So once it exceeds this particular sorry, on 3 itself, when you call this on index 3, it will be exceeding, like it's greater than or equal to n, the n equal to 3 in this case. So you'll be coming to an end of the recursion, so you'll be returning 1. Okay, returning 1 in the sense, yes, we have got a particular path. So this would be one path, this would be another path. So all those subtrees are possible. I hope you people have understood. And finally you'll add them up. Okay, finally you'll add them up. This is a very easy recursion, just working on 2 variables. You can easily write it. If in case you're not able to, let me know, I'll put the code as well. But that is very complex, because the time complexity is O of 2 power n, because for everything we have 2 choices and you'll be working on 2 power n, but n goes up to 10 power 5 here, so you cannot do it. Okay, I hope you people have understood that particular point. So I'll just remove this particular thing. I hope you people have understood this thing, that so now after seeing that Fibonacci, or at least after realizing that this is a recursion question, I came to an understanding that yes, it depends on the previous values, but what is the relation is what I need to decode it. So let us assume, first let us start with n equal to 1. Okay, n equal to 1. If n equal to 1 in the sense, there's a road here and there's a plot here, right? N equal to 1 in the sense, there's a plot here and there's a plot here. What are the total possibilities that I'm getting? I'm getting for the on one side. Okay, on one side, either put a building here or leave it empty. Okay, or put a building here, leave it empty. So there are 2 choices on one. So I'll write this, choice is equal to 2. Choice is equal to 2. Remember, we are working on only one side of the road. So because on one side we have 2, on the other side also we'll have 2. So the total would be 4. Okay, so choices denotes only one side and total denotes on both the sides. Remember that point. Now come to n equal to 2. Okay, now come to n equal to 2. So this is like this, a plot, road and plot. So what are the things right now that are possible? Either I can put here B. If I start with B, if I put a building here, the only possibility that I'm going to have is an empty space. But if I start with an empty space here, I can put a building. If I start with an empty space, I can put an empty space at this point as well. So choices are equal to 3. Okay, so the same choices will be on the either side of the road as well. So total would be equal to 3 into 3, that is actually equal to 9. Okay, so choices means on one side of the road, so do not confuse. Now come to n equal to 3. So n equal to 3 in the sense, the same thing, right? The same thing in this particular example too. So what did we decode there? N equal to 3. What did we decode? So where we have decoded that, if this is the case like this, the choices in the sense, on one side of the road, we'll be having a choices of 5 and total equal to 25. This is the total on combining both the sides, but only if you're working on the one side, you'll be having choices as 5. So do you find any relation here? The first, for n equal to 1 you have 2, for n equal to 2 you have 3, for n equal to 3 you have 5. So do you see a relation? Yes, it is a Fibonacci, right? So 2, 3, 5, 8, it goes on. So how are we getting a Fibonacci? Add the previous 2 numbers to get the present number. So this goes on, and here you'll be having 13 and you'll be having 21. It goes on, right? So for that to check, I have written this particular 3 as well. So if you're taking n equal to 4, you have 2 choices, start with B or start with S. B in the sense put a building, S in the sense leave it empty. So if you're putting a building at this first point, so these levels, okay, these levels denote the position, first position, second, third and fourth. So if you're putting a building at the first position, then you'll be having only one choice to leave it empty in the second position. And once you're leaving it empty in the second position, you have 2 choices for the third position, put a building or leave it empty. So the same goes on. So similarly, if you're leaving the first position to be empty, you have 2 options for the second position, either put a building or leave it empty. So it goes on. So totally 8 possibilities are there, 8 possibilities, and this is are from one side of the road, and for the other side also we'll be having 8. So total 8 plus 8 into 8 equal to 64. But that is not important. If you carefully see, 8 is actually equal to 5 plus 3. What is 5? On one side equal of n equal to 3, right? N equal to 3, you have one side to be choices to be 5, and for n equal to 2, that is previous second, so that is actually in this particular position, so you have choices to be 3. That is what I have written. So 5 plus 3 denote that. So what are we trying to come to an understanding? That if you are trying to work on one side of n, one side of n equal to one side of n minus 1 plus one side of n minus 2. This is the relation that we have got. Okay, one side of n minus 2, and total would be just the multiplication. So whatever you have got, just multiply that. One side of n of into n. That's basically whole square. Okay, one side of n into one side of n. I hope you people have understood. The same thing I've put in the code. The same thing that I've put in the code. So if n equal to 1, return 4. We have decoded it. N equal to 2, return 9. But what if this is not the case? N equal to 1 is not the case. N equal to 2 is not the case. They have given some other n value. Then take mod and previous 2 in the sense 2 and previous 1 equal to 3. That means the last term, because if you're like working on this particular thing, okay, so if you're working at n equal to 4, you need to have n equal to 3 and n equal to 2, right? And for n equal to 3, you need n equal to 2 and n equal to 1. So this is what I mentioned. This is the previous one and this is the previous last, okay, the last two numbers, because it is Fibonacci. How are you going to do Fibonacci? If you want to calculate the particular value, you need to have the values of the last two elements. That is what I've written. This is the previous one, this is the previous two, last two elements. Okay, so starting from I equal to 3, I less than or equal to n, I plus plus, your present value is equal to the sum of the previous two values. Okay, previous one value plus previous two previous two plus mod, just to make sure it is not, you know, overflowing. And then your after this, your present two would be, previous two would be your previous one, previous one would be your present, isn't it? So once you have calculated for this, now for if you wanted to calculate the next one, so this would be your previous one, this would be your previous one, this would be your previous two, isn't it? Very simple. So that's the reason I have updated the particular values. So write it on a paper if you're not able to understand, decode it, write it on use a pen and paper, you'll be getting a better clarity. And finally, long total, that would be your present value. After you reach the n, you'll be just multiplying them and finally return it. Okay, I'll even submit for your reference. It worked properly. I've already checked, so there is no need to check, but it's for your preference. Okay, so it's working properly, fine. So the same code I put it in C++, Java, Python as well. Go through them. I put in the description. I hope you people have understood. Very good question of, you know, relating with Fibonacci. I was really not able to figure out it is a Fibonacci until unless I saw this till I saw this particular Fibonacci in the topic tags. That's the reason it's very important to go through each and every segment of the question that has been given. Okay, so that's it guys for this video. And also for your thing, I just wanted to mention I've created a WhatsApp channel and there are 700 members in there, in that particular channel, and posting off-campus opportunities. So if you're looking out for some opportunities like that, do consider joining it. The description in the link of that particular channel is there in the description. Okay, so that's it guys for today. So thank you for watching. Stay tuned.